Today, I will be guiding you towards the topic of testing of power capacitors, which is presented to you by Vedant Singh, Tanvi Chimte, Bavrica Kaur Sudin, and Vaishali Mankar. And this topic is guided by our guide, Mrs. M.H. Deen ma'am. So, what is a power capacitor? A power capacitor is a device that stores energy within an electric field. This can be achieved by having two oppositely charged electrical conductors separated by dielectric materials. Power capacitors are constructed for several smaller capacitors commonly referred to as elements, windings, or packs. Elements are connected in series based on the rated voltage and in parallel based on the required kVAR. So, why are the power capacitors required? In distribution system, these power capacitors provide reactive power to offset inductive loading from devices like motors, arc furnaces, and lighting loads. The incorporation of power capacitors into a power distribution system offers economical and operational benefits, including increasing system loads capacity, reducing losses, and improving power factor. So, what are the different components that are used? These components that are used are formed by multiple layers of aluminum foil, those are the conductors, and a polypropylene film, that is the dielectric wound together. When they are interconnected, multiple elements combine to function as a single capacitor unit. Elements are connected in series based on rated voltage and in parallel based on required kVAR. The completed module is enclosed in a hermetically sealed tank, and any air from the unit is removed and replaced by an dielectric fluid. The units include bushings with terminal caps that are used as connection points and to maintain electrical creepage and clearance requirements. What is the basic principle or the principle of operation behind power capacitor? Capacitors are essentially components in power factor compensation circuits. They can be installed in parallel with the load for compensating inductive load by supplying appropriate amount of reactive power in the circuit. Why do we need testing? Why is the testing required? There's moisture, time, harmonics, and temperature changes, the power factor corrections, and due to which we require power capacitor banks. Already installed power capacitor banks, if they are not tested or unmaintained within the specific time, becomes incapable of functioning at their finest levels. So, with time, the operation of power capacitors can weaken, decreasing the power factor of your power system, resulting in power factor loss. 5 testing methods that are used: loss determination, voltage decay test, capacitance test, dielectric test, power frequency voltage test. The first one is the loss determination test. This test is performed on each of the capacitor unit. The loss that occurs in the unit during the operation, if it is less than the maximum allowable loss of the unit, then it is known as the loss determination test, which is being carried out. Second is the voltage decay test. Here in this test, the capacitor unit is charged with the direct voltage whose value is equal to the peak value of the rated alternating voltage of the unit. After the charging is done, it can be discharged by some means and the decay of the voltage is measured. If the voltage comes down to less than 50 volt within 5 minutes, in the case of capacitor unit rated higher than 600 volts, then the unit is considered as passed in the voltage decay test. This voltage decay should be within 1 minute in the case of capacitor unit rated with lower than 600 volts. Next is the capacitance test. This test is done to ensure that each of the capacitor unit in a batch or a lot should give not more than 110% of its rated VAR during normal operating condition. that is, charging application of rated voltage and frequency to the unit within possible temperature limit, which is considered as degrees Celsius. If the measurement is done at a temperature other than 25 degrees Celsius, then the measured result should be calculated according to 25 degrees Celsius.
And in this case, we're measuring 82.2 microfarads. So what does that mean? Well, that's the measured value, and in order to assess whether or not that's correct, you need to go to the information plate on the capacitor itself, and that could be at different locations depending on the brand of capacitor. This is a GE capacitor, and so there's a information plate riveted to the mounting bracket. So if we look at that plate, there should be a value on that plate from the factory. And in fact, it reads 82.2 micro 2. So they in fact match exactly. So we know this capacitor is good. If it was partially failed, 10% is usually the value that we consider the good range. Anything over 10%, we consider that a failed or failing capacitor. The other situation would be a completely shorted capacitor or possibly an open.
Be seeing is the dielectric test. In dielectric testing, a high voltage that is typically greater or equal to 1000 volt is applied between the two conductors that are supposed to be electrically insulated from each other. If the two conductors, for example, an insulated live wire and a metal enclosure, are completely isolated from one another, then the application of a large voltage difference between the two conductors would not allow current to flow between the conductors. In this case, the insulation is said to withstand the application of a large voltage potential between the two conductors. Next, and the final test we have is the power frequency voltage test. The apparatus is subjected to the 1-minute test for under 50 Hz or 60 Hz. The power frequency voltage withstand test is performed to examine the insulation strength and whether the partial discharge occurs. Following, we come to merits and demerits. Considering the merits, we have that we can charge and accumulate energy quickly. We can deliver the stored energy quickly in power capacitors. Losses are small compared to the other storage mediums, and the long service life and low maintenance are also the merits of power capacitor. While the power capacitors also have demerits such as low energy capacity compared to batteries, limited energy storage per dollar cost, stored energy will eventually deplete due to internal losses. There are numerous applications of power capacitors. There's reactive power The work distribution is done as followed. Tanvi has presented with the PPT and has contributed with explanation. Vedant Singh has prepared and edited the PPT. Bavrica has been collecting the resources that were used for the PPT. Vaishali has been contributing towards query and resolution. Thank you.